Hey guys, I'm Lisandro, and today we're gonna build a homemade capacitor. But before we start, we're gonna get some things clear, like what is a capacitor? Well, it is a two-terminal electrical component used to store energy electrostatically in an electric field. But to put it on easier words, imagine a capacitor as two conductive metal plates separated by an insulating material called dielectric. When this capacitor is powered, his two conductive metal plates are positive and negatively charged. The dielectric material between the plates does not let the electric charges touch each other, but the force that attracts them is so big that it creates an electric field. Now, the great thing about capacitors is that the electric field is so strong that it keeps the electric charges in its place attracted to each other without leaving the capacitor, well, at least not immediately, being able to store that energy and be discharged later. If you think about it, it sounds like the function of a battery, but do not think that they're the same. The principal difference is that a capacitor is able to get charge and discharge from very fast to very slow, but the battery is made to take so much time as it can before it gets discharged. When we take a close look to a capacitor surface, we can see two big numbers. One, which stands for the maximum voltage that capacitor can manage, and the second, which stands for the capacitance, which is expressed as the ratio of the electric charge on each conductor to the potential difference between them. That is the capacity of electrical charge for each volt. The capacitance is measured in farads, named that way because of his inventor Michael Faraday. But there's another way to calculate capacitance, through this formula, which says that capacitance equals E times S divided D, where S stands for the conductive metal plate's surface size, D for the distance between these two, and E for the permittivity of the dielectric material. This formula lets us know two important things. One is that the surface is directly proportional to the capacitance, and then the distance is inversely proportional to the capacitance. In other words, the larger the surface and the smaller the distance, the greater the capacitance. Knowing this is what is going to lead us to our experiment. To build our homemade capacitor, the materials we're going to need are aluminium, paper, tape, copper cable, and some scissors. First thing we're going to do is take our aluminium and cut a piece big enough to fold it in half and cut it in half again, that way to get our two pieces of conductive material. Next step is take our paper and measure how much of our aluminium is going to fit in it. Now we take our copper cable and we cut in half. These two pieces are going to be the legs of our capacitor. Now we take a piece of tape and fix the first of our legs to the conductive material. Once we're done with that, we take our paper and cover completely our metal plate. Then we take our second piece of aluminium and put it over the dielectric material and fix the second leg. If we remember the formula explained before, the larger the surface of the conductors and the smaller the distance, bigger the capacitance. So what we're gonna do is fold our paper so many times as we can and see how much our capacitance grows. and resume with a simple piece of paper, copper cable, and aluminium we created a 9.4 nanofarad capacitor. It's very low, but it's still awesome.